Guys, our today's agenda is big data. What is big data? So let me open this. What is big data? Some information about the big data, different dimensions about the big data, and why suddenly the big data became that much big buzzword in the industry. Then after that, we are going to see, okay, before the big data technologies, there were surely some conventional technologies. What were those technologies and what were the problem with those conventional technologies? Then we'll see about the big data, enter into the world of big data. So guys, can you see the very first screen? What is big data? Waiting for your smileys. 1, 2. Okay, that's great. So guys, every day, so these are the few statistics that I have gathered. Every day, world create 2.5 quintillion bytes of data. So much data that 90% of the data in the world has been created in just last 2 years alone. So guys, you can imagine 90% of the data is generated in last 2 years. Means before, prior to last 2 years, whatever data we have generated, that is just accounting 10%. What do I mean by that? Data growth is exponential. It's not linearly increasing with time. It is pretty much exponential. According to Gartner, big data is a high volume, velocity and variety of the information assets that demand cost-effective, innovative form of information processing for enhanced insight and decision making. What do I mean by that? So big data is not just the volume. It's not like, say, I have got 1 petabyte of data, that is big data. It is just a single dimension. Second dimension is a velocity, the speed at which data is generated and the speed at which data is consumed. Variety, different varieties are there, like structured, semi-structured and unstructured. Apart from that, there is one more dimension that is that comes little late, that is veracity. And today there are multiple dimensions like volatility and validity are also introduced with the big data. Now, according to IBM, 80% of the data captured today is unstructured. So guys, what is unstructured data, by the way? Anyone? If you can ping me. Not in standard format. Video, images. Yes, correct. Both the answers are correct. Simple example, if I say this paragraph in front of you, it's an unstructured data. Whatever posts we are doing in the social media, whatever say images we are sharing, whatever videos, audios, and say for example the sensors that are generating the data. Yes, correct. Facebook and Twitter's data, again a form of unstructured data. So if I start from the very beginning, so the climate information that is collected from the satellites and the sensors, post to the social media sites, digital pictures and videos, purchase transaction records, and cell phone GPS signals. These are the major contributor in the generation of the big data, and these are the unstructured data. So guys, apart from, so you understand the, okay, unstructured data on which we can't put a structure, that is we can't store the unstructured data into RDBMS. So all of you guys, since you are pretty much experienced, many of you are pretty much experienced, so guys, till now you understood the data that is in form of rows and columns, right? But this is a very small amount of data that is generated in this form. Major data that is generated is unstructured. So guys, you need to change your thinking of the data. So for now onwards, data will be a bucket. You are going to get a bucket with full of data. It's something like this. So it will take some time, I can understand, but try to think data like that. Okay. Now that's a very basic about, okay, big data. What is big data? Now before looking into the different dimensions of the big data, let's talk about why big data. What happened suddenly in the industry that everybody started talking about the big data? It's not like that just from the past year or past 2 years only the huge volume of data is getting generated. Data was getting generated, that was still huge, but suddenly there is a huge competition in the market. So guys, I would like to share various use cases so that you can connect with this. Okay, in which use case you can use the big data. Say for example, if we visit any website, let me take from third one, that is website. Let's take the example of say Amazon.com or there's Flipkart.com. These are the e-commerce website. You know there is a every 5 seconds a product is getting sold on Flipkart, and this figure is 6-7 month old. So today it's even more than that, more frequent than that. Whenever a user is clicking on the website, whenever a user is coming to the website, they are capturing each and every information of that user. Like, what is the source, whether the user is coming from Google or from Facebook or directly. What is his landing page? Say he came to for on the mobile section. Say he came on S5 mobile. What is his navigation pattern? So from mobile section, so he went to say headphones, then he went to say speakers, then he went to laptop. Whether his visit has converted or not, he ended up with purchasing something or he went away. He entered into mobile section, or whether he entered mobile or he has purchased mobile or he has purchased say laptop. What is his area of interest? So as many of you know that guys, today all the e-commerce websites are providing recommendations. So guys, any of you know about recommendation? What is exactly this? How, on what basis they are recommending us the product? If you visit Flipkart, they are on their homepage 3 to 4 types of recommendation. Recommendation based on your browsing history, recommendation based on your interest, and different type of recommendation on different sections. Say on laptop section, different recommendation. On mobile section, different recommendation, like that. Any one of you? How they are recommending us the product? And that is even on the fly. As soon as you visit the website, all the things come up suddenly. No one? Okay, no issues. Okay, no
There
issues.
might be some offers which might be suggested for you.
Sorry, please come again, Udit.
So I was saying, like, I mean, if you take the example of our cell phone, our
Mm-hmm.
texting, assuming if the age group below 20 years, if they are using more texting, so there might be some offers which might be given to the person who is of age group below 20 when he called up a CSR or a customer service representative. That's one way you can give, you can upsell your products,
Yes, yes, correct.
Yeah, I have one
or you
example
can.
also.
Correct.
Hello.
Yes, yes.
Yeah, one more way is uh, uh, like a clickstream behavior analysis. Like generally, the user comes and visits the sites over the period of time, like his views, clicks, the online campaigns. That all this data is captured, and all this clickstream behavior is analyzed, and then based on his browsing history, the recommendations will be made and browsed on his purchase history back he made that. Based on that, also the recommendation.
Perfect. Perfect answer, Riaz. I would like to add few things in Riaz's answer. So Riaz, what happens that, so guys, all of you, what happens that whenever we do visit any website, they are capturing our click streams. Whatever we are clicking, they are capturing each and every of our click. Okay, we are clicking on this, we are clicking on that, and all such things. I think somebody's mic is still unmuted. Please mute yourself. I'm getting some disturbance. Yashwant, please mute yourself. Thank you. Yes. So whatever we are doing, whatever, say for example, we are visiting them, we are purchasing anything, or we are not purchasing, or from which section we are entering, which section we are exiting, all such behavior they are logging. Say for example, so say Flipkart is 5 years old now. Flipkart has got his historical data, that okay, whoever people are entering from this particular location, from this particular page, from he has visited these pages and he has purchased this. Say he has the example like entered from Facebook, or entered into mobile section, purchase laptop, or purchase headphone, or something else. Now guys, what happens in the background? So that the thing that looks that much real time, that okay, in real time I'm getting all the recommendations and all. So in the background there are very complex algorithms are running on my all historical data. Is this Flipkart is having petabytes of data in their Hadoop cluster, which is doing this recommendation work. They are analyzing each and everything, and due to that only they are providing that much good recommendation. The recommendation of Flipkart is like anything. So from the user's navigation pattern, from their click stream, and from their purchase records, all three things they are providing the recommendation. So guys, it is quite unusual that if you visit, if you say see one product, and if you see recommendation, so you surely see those products, okay, these are the quite similar products, and your chances of purchasing the same product will be much higher, because you will get a comparison of say all these are products available in the market, I can purchase any of them, or okay, I'll purchase this. Due to this, the sales of Flipkart has increased like anything. So this is the third one. Let's come from retail. Let me share one use case. So I have recently worked with a retailer, leading retailer in India. So guys, there we have worked on a use case that okay, if a person say Uruj went to a store, he has purchased say bread and butter. What is the probability that Uruj will purchase milk also? I can find out that. By the way, in a specific store, there are more than a million products are there. Around a million products are there. So if I can find out, okay, if a person is purchasing product A and B, if the probability is of he will purchase a product C is very high, I can put these three items together. I can put butter, bread and milk together. So if a person will see, okay, the third item in his front, the probability that he will purchase the third item will be very high, up as compared to he need to search to the complete store for searching for the third product. We have implemented the same thing in one of the store, and the store's sales has been raised by 24%. 24%, guys, it's a very huge figure. Very huge figure. Yes, Uruj, please.
Yeah, in fact, like I mean, one way of selling such products is like guided shopping, wherein what I'll say is if I purchase so and so item, next items are within the same screen. I'll show all the related items. So are we saying that we need to have some kind of pre-decided items within which it has to do some analytics and then find out what is the probability of.
Yes, Rich, correct. We need to make our store customer friendly, that much customer friendly, that user, whatever is coming to user's mind, it should be in front of his eyes. It's that much like that. How? I'm having my past say 5 years of my sales data, from which I can easily find out all such things, all such patterns. Okay, whatever is, if user is purchasing these two products or these three products, his probability to purchase the next product, or which product he will purchase. What? So this is called a typical application called market basket. So what a person will put in his basket, what are all the products, so I'll put maximum of them together. All such things are analyzed today and are implemented. So Walmart is implementing the same, Reliance is implementing the same, and even Big Bazaar is also implementing the same, started implementing the same. Walmart is using this like anything.
Okay.
Apart from this, if I am purchasing any product, say let's talk one more thing of e-com website only. I'm taking an example of Velocity, by the way. Say Shiva has selected butter in his cart, say Amul butter. As soon as Shiva select Amul butter in his cart, if I can provide him in just 1 second, in 1 second, if I can provide him an advertisement, if you purchase Britannia butter, there is a 20% discount. Guys, just imagine Shiva at the client side, his location is very different. The data needs to travel from the client location to my analytics. In analytics, I need to compare, okay, what are the offers currently available. Then I need to send the data back and the advertisement pop-up will arrive. All such things I need to do in real time in 1 to 3 seconds. If it is more than 3 seconds or if it is more than 5 seconds, he has done the checkout. He will not care about whatever advertisement they are giving. So what I'll do as e-com manager, I can do the partnership with say Britannia Butter. You provide me 30% off, I'll make your sales increase by 40%, 50%. Similarly, so out of that 20% profit I'm giving to my customers and 10% is in my pocket. In the real time, when a person is purchasing and when a person is selecting any product, I can show him the advertisement in real time. How many of you have seen such type of advertisements, by the way? Uruj, okay, good. Only Uruj has seen, nobody else? Okay, might be you didn't okay, Shivi is also seen. Shiva, okay, that's good. Apart from this, guys, whenever we are doing travel, so guys, if you are using any of the smartphones, say I'm using Android phone, so many of the applications are tracking my locations. Every day in the morning I'm getting a pop-up time to work, evening I'm getting a pop-up time to home. At a specific time, usually at what time I leave for office or at what time I leave for home. I haven't done any setting I haven't done. It is the travel pattern that these apps are logging, and they are sending as anonymous as they are sending this to server, and accordingly are so guys, there are multiple projects. Even some of my teams are also working on similar project. So if you are traveling, say for example via say your car, you are driving from Delhi to Mumbai. So while you are driving, say you are 30 kilometers away from Delhi, say you are at location XYZ. So whatever things are near to you, whatever good things are near to you, you'll automatically get a pop-up. Okay, visit this particular museum, it is quite a famous at this place. Visit this hotel, this is very famous, this is very good, and the ratings of the hotel is there. Visit this petrol pump, this is so. All such developments are currently in place. So soon you are going to see such things also, and even some apps are already available for the same. Currently are all the travel pattern is getting logged. Apart from this, let me take travel plus advertisement pattern. I have done I traveled recently from this Mumbai to Delhi. So I was in Mumbai for 2 months at that time. So for last 1 month I was in Mumbai. I have done that particular ticket from Make My Trip from my office laptop. I was logged in on Google. I have done that ticket. Okay, that so for the return ticket for Delhi to Mumbai, I did it at my home. I was not logged in, by the way, at that time. For next 7 days, I was keep getting new advertisement for a return flight from that Delhi to Mumbai. This much percent off from Make My Trip, from Travel Diary, from this, from that, and all such things. So guys, just imagine this analytics has penetrated to our personal life to this level. How many of you know that? How many of you have seen that whatever type of mails you are getting, whatever type of mail, say for example you are searching for a job, so you are keep getting the advertisement in your Gmail related to job. If you are searching for say if you are interested in purchasing a mobile, you're getting a mail for mobile, you'll get the similar advertisement in your mailbox also. If you want to travel to some places, you'll get the similar advertisement in your Gmail. I'm talking about. How many of you have seen? How many of you have noticed? Shirish, okay. Riyaz, Venkat, good. Yashwant. Guys, now what I want to say, the advertisement that is currently being shown to Shirish is different, to Uruj it's different, to Shiva it's different, to Yashwant it's different. Just imagine there are billions of users of the Google, but the pattern, the way of showing the advertisement, it's not broadcasting advertisement. It's depending on users' interest. If you are today are interested in mobile phone, it will show you that mobile phone advertisement. Tomorrow for say LED, then it will show you LED television. This analytics we don't know, but analytics has reached to our day-to-day life, our thinking. It is analyzing what we are thinking, whether we are liking this or not, what things we like, what places we like to travel, what things we purchase. Okay, so guys, that is a very brief about what are the application that is currently being built around this. So let me take few more examples. Say take the example of telecom. So telecom industry is, say for example, recently I worked with TTSL. So guys, from the network element called AAA, from the network element, this is not exactly this is the terminology that I think Uruj understand. Uruj, the AAA is the exact end element or something else from where we get the ASN data?
I mean, that's basically a network element from where you get different types of data.
Okay. So from AAA, we are going to get the data from the end element also that's serving to the client from that's with the tower that we are getting the data. Now, in the real time, we want to generate the reports. In the real time, we are collecting the data and we are generating the reports that the network signals that it is serving, whether that is weak or not. If it is weak, there will be urgent alerts are going to send to the management from all the circles across the India. Such type of application is currently getting developed. So in real time, petabyte of data is getting generated daily, and that is petabyte of data getting collected daily and processed, and the reports are being sent. As soon as if some tower is not performing well, rescue team immediately or team will go and will check, will do the actionable needful they will do. Apart from that, so I'll come for that this customer churn issue in next few slides. So that is one example of telecom industry. One of my friend is working on a very important project that's I would say whatever I've worked it till my date is not having that much value. It's for the cancer patients. Guys, as many of you know, that's very bad disease, and whenever unfortunate person got this disease, he needs to go for the therapy. And after the report from the cancer, the doctor needs to do some sort of try on his experience and trial basis. He will apply for a specific therapy. There are, by the way, 4 to 5 types of therapies are there. Now, according to his experience or whatever he thinks, he will apply for a therapy. Now, if that therapy suits to that patient, well and good. If not, he will apply for the second therapy. Again, not good. Third therapy and so on. Applying a specific therapy is very painful. It's like it is providing you, it's giving n number of side effects to your other body parts. So my friend is working on a project that is getting input of the diagnosis of cancer, the report of that, the image that he is going to get. So by the way guys, a single image size is 600 GB. 600 GB image he is getting. So that image is firstly digitized, and after that that is getting processed, and now that algorithm is giving which therapy should be applied to that patient. So currently with very big hospital client he's working, that's US client he's working currently. It will be in some shape by next 4 to 5 months. So that's quite a good, quite much I say the one of the best project products in the industry. So this is the second, by the way, this is the second example of that's in healthcare. Retail industry I have already given, travel I have already given. Apart from that, banking I'll give you a little later. Now we'll keep discussing a number of use cases. Sensors, satellites, and geospatial data. Again, they are adding the huge volume of data. They are generating the huge volume of data. They are one of the major source for the data generation. How many of you know that military and intelligence is also using the big data? White House has invested $100 billion in big data. $100 billion. They are crawling our each and every information. They are crawling each and everything that is going over the internet. They are seeing that okay, whether that person, what is thinking, what is calling, what is browsing, what are the overall is there any suspicious movement, is there any this terrorist movement, is there anything via the satellite. They are capturing the data. There are different sensors crawling the web and all such things. This is currently being used by the military and intelligence of n number of countries. US is amongst the top amongst them. Obama won the election using big data. Perfect example, Shiva. I'll discuss this thing in great detail in next few slides. So guys, Obama is again a big data president. So 100 out of 100 marks for his win goes to big data. Let's move ahead. Guys, these are the essence of big data. Heard of usage in cricket. Use, you can speak. I really didn't heard about this cricket especially. I'm also pretty much interested if there is some use case in cricket.
Yeah, in fact, like generally these days, if you see the pattern in which the bowler has been bowling or the wicket, like I mean, what is the probability that if it is bowled in this way, this guy might give a catch to catch at so and so location.
Is
So
it?
you can generally see these days. Yeah, I
Oh,
mean,
that's
I
good.
heard like I mean, big data is being used in that particular operation.
That's really good. That's really interesting. By the way, I have stopped watching cricket for quite a long. That's really good thing. Means I'm already a die-hard fan of cricket. Means when there was Sachin, I was watching cricket. Then after that, it's quite low. Means no, not watching. That's really interesting. So guys, these are the four major, I should say, dimensions of the big data: volume, velocity, veracity, and variety. Let's start one by one. Volume. So as the volume is pretty much clear from its word, volume, that's huge data, that's in terabytes to petabytes to even zettabytes. Today we are living in the world of data. There are multiple factors contributing in the data growth. Huge volume of data are generated from various sources. For example, transaction based data. So guys, can you imagine how much data is getting generated for the retailers in India? For retailers, like you can take any example. By the way, what is the format of the data that is for the transaction data is getting generated? What is the format of the data? When you go to any store, say for example to Big Bazaar, you are going to pause, that is point of sale, and you get the bill there. So what is the format of the data that is getting generated?
I think that's a structured format.
No, that's not structured. Anyone else? Semi-structured? Yeah, I can say it's semi-structured. What is the format? Guys, the format of the data is XML. XML looks a little structured, but it is considered as semi-structured in the big data. Now, let's talk about the volume. Volume of the data is quite huge. I worked with one of the retailer in India, and they are getting 100 gigabyte, 100 GB data per day. It's really huge. If you talk in terms of, say, just the transaction data, invoices, because they are capturing n number of client information, n number of customer information. They're providing different cards to the customer for the loyalty, and they are capturing their all the information. Even they are capturing the information of the person who is doing the billing. Say for example, if a customer, if the person that biller is doing the billing, how much time he has taken to bill. Say for example, if a customer has purchased 50 products, so from the first product till the last product, how much time has been spent, so that by which they are doing the analytics over those person also, those employees also, so that how much fast or efficient they are, what's the location, what's all the user information, store information, and then product information, all the offers, markdowns, and all such things. Can you imagine the in a single leaf of the ticket, in the single ticket, how much data is getting generated? How much fields are there? 167 fields are there. I mean, it depends, it varies with different implementation, but I'm giving the figure of one of the retailer. 167 fields. So guys, let me give you one example. Very interesting story. I was in the big data field for almost last 4 or 5 years, 4.5 years. So I'm a die-hard fan of big data. People do not understand. People think that, oh, you're challenging my this much years of experience, this much and that much. When I visited that retailer, so they shown me that issue. Okay, these are the issues that we are getting that much huge volume of data, and they have their conventional technologies. So I'll give you details in the problem section. I'll give you detail about this, what they are conventional technologies and all. But the processing done by them, which involves validation, verification, and a number of business rules needs to be applied on after that. It's taking 10 hours to process this data. 10 hours, guys. 10 hours is very big time. So at 3 a.m. in the morning, they are getting the data of past day, and it will take another 10 hours to process the data. But their requirement was they want early alerts, message alerts, and all such things, early mail alerts to the business, so that they can take the action if required. They can understand, okay, what was previous day's sales and all such things. But they were unable to get it. And the configuration of the system is 500 GB RAM, 128 core processor, TBs of hard disk. This was the configuration of the system on which it was running. When I visited them, I was discussing their problem with their VP. So his expectation was, if you can make it 5 hours, 50% by using your big data technology, so-called big data technologies, he was saying like that. So guys, I smiled at that time and I told, okay boss, I'll try. I just told him that I'll try. I didn't assure him. When I implemented the same thing in Hadoop and MapReduce on a cluster of 10 node, 10 slave 1 master, on a cluster of 10 nodes, the same processing has been done in 10 minutes. Guys, I'm not joking. It's 10 minutes. Yes, that's the power of big data. That's the power of Hadoop. When I shown the demo to, when I shown the PPT and discussed this with him after 4-5 months when I visited them, the VP didn't accepted this. He told that it's not possible. You're joking. You're what you're doing. You're playing with this. When I shown him the proof of concept of the same, his mouth remained open. He told that, boss, you have done the magic. What you have done. This is what means we can't even imagine. This is what we can't expect. So guys, that is the power of Hadoop. That's the power of big data. Such things on the conventional technology is pretty much tough, pretty much sequential, and takes huge volume of time, huge amount of time. So by the way, hang on your questions for this particular use case. I'll discuss it in great detail in next session also. So how Hadoop is doing the magic. Hadoop doesn't do any magic, by the way. It's the native capability of Hadoop that provides the thing. Now, other factors, other sources that is contributing in the volume are text, images, videos from social media. Increased amount of data generated by sensors. So currently guys, we are having quite a good sensors which can predict earthquake, which can predict floods, which can predict a number of different cyclones and all. But they are also generating huge volume of data. Guys, you know, the data that is generated by a plane, a Boeing plane, for their 1 hour journey, it generates TBs of data, terabytes of data. 1 hour journey, terabytes of data. So if I collect all the 1 year's data, no, not 1 year's data. If there are 100,000 flights per day, so per day's data, how much a day data will be generated per day? Any one of you can imagine? Any one of you, if you want to just guess a figure? I don't have that slide currently with me. It will be might be next PPT. Shri is saying PBs. Still, Shri's PBs are too small. The answer is in exabyte. That is 1 million terabyte. Exabyte. That's huge volume of data, far beyond from our imagination. Even today also I can't imagine exabytes, the number of zeros. So guys, let's talk about few use cases. Turn 12 TB of tweets collected each day into improved product sentiment analysis. How many of you heard about sentiment analysis? What is sentiment analysis? A very interesting project that is being done by almost all the customer facing industry. Sentiment analysis. I'm sure many of you know that. Uruj, Shiva, Venkat. You can speak, by the way. You can unmute yourself. You are unmuted from my side. Guys, can you hear me? Okay. No one heard about
Not
sentiment
very sure,
analysis?
but at least
Yeah.
not really heard about it, but might be like from the text. What I can guess is like maybe based upon, let's assume I discuss about a particular automobile car. So multiple people discussing about that. Based upon that, the sale of the car might be going up.
Yes, somewhat correct. I got a correct answer from Shiva. Attitude of the speaker is the sentiment of that particular thing. Yeah, correct. Let me explain you. So guys, this is very interesting thing that's currently booming up in the market. So as I told you, almost all the customer facing industry, almost all are doing this project in them. So I have implemented the same project with 3 clients currently, the same project that we have developed for. So it is currently about to become a product for us. Now, what is exactly is this? Usually it's people's tendency, not that much in India, but in US and UK, whatever they purchase, they write about that on the Twitter and the Facebook and so on. Let's take the example of Disney, for which I have firstly deployed this project. They are having huge follower base on Twitter. Now guys, just imagine if after launching a service or a product, I can crawl this particular say Twitter, and I can get the sentiment analysis of the users. How many users are how much percent of users are saying positive? How many of them are saying negative? Say 80% of the people are saying positive. It's a very good product. say 80% are saying negative, it's a big flop, just stop production, just start, there are some issues, just take immediate action. It's like people will write about the products, projects, services, whatever is coming to their mind, they are writing about that. Now our thing is we'll crawl that data and we'll find out, okay, whether they are saying positive or negative. So their sentiment we are finding out. According to their sentiment, we can find out, okay, whether the product we have launched is good or not, isn't it? Let's take the example of Obama. After giving a speech while his election campaigns, after giving a speech, Obama crawled the complete web and he found out that, okay, what people are thinking about his speech. How? So he crawled the web, say region wise, say in New York, say in California, say in other states of US, different states of US. What people are saying about him, whether positive, negative. Say only, not only in US, but also in, say, India, China and Russia. Apart from that, second dimension was after, just after his speech, after 1 hour, after 1 day, after 1 week, after 1 month, and so on. He crawled the complete web and find out, okay, what's the people's sentiment. He crawled the web, he crawled this news, this media sites and the channels. What they are saying about his speech, what they are saying about him. Accordingly, guys, after doing all such analysis, he takes the corrective measure in his next speech. So say for example, he has given a speech in New York, say on a specific date, and he found out, okay, people's sentiment is say 70% positive, 30% is negative. Now after that, he can also find out what people are not liking about this. People are not liking his comment on, say, Iraq. People are not liking his comment about, say, XYZ. Accordingly, in his next speech, he is going to change it. He's taking the action accordingly. Okay, what people are liking or not. So guys, this is the typical use case that that's a real use case that Obama has used, and he has become the president again. You can, by the way, you can also do a little bit googling about this. You'll get a complete case study about the same. It's quite a nice thing, really. That's the power of big data. So by analyzing the sentiment of the user, we can find out the whether that tweet is positive or negative. So apart from this, so guys, by the way, volume is in TBs per day. Per day volume is in TBs, or might goes beyond that. The next thing is convert 350 billion annual meter reading to better predict power consumption. Turn billions of customer complaints to find root cause of the customer churn. So guys, which industry in India currently is facing the customer churn like anything? The biggest means the pain that industry is seeing that, okay, this is the biggest pain, customer churn for them.
The service industries,
Okay,
like most of the service industries based upon the service they provide.
for example.
Assuming example, if I am a Vodafone customer, Vodafone doesn't provide a better
Exactly,
service.
exactly. So if I say any specific thing, it's your industry, your domain only, that is telecom domain. So telecom domain, since there is a portability in India, recently arrived just last year or so, last 1.5 year. So people are shifting from one telecom operator to another if they are not feeling that the service of the operator is good. Guys, this is a very big pain point for the companies like Tata Docomo, the companies like this, what was the second company? I forgot. And the company that gained like anything is Vodafone and Airtel. People left from Tata Docomo, people left from Reliance, and they are going for Vodafone and Airtel. Now, the headache for Tata Docomo is that why people are going. He can't understand. So they are whenever a person go for the procedure, the long procedure for the portability, he will surely do at least one complaint. So from the user complaint, from the customer complaints, via crawling the data from various social network sites, via crawling the data from various complaint sites, via crawling the data from various user review websites, apart from that, your own customer complaint and customer care data, you can crawl and you can find out the root cause of the same. Again, a very good use case for this. That's all about the volume. Velocity. Now guys, as the volume is quite an obvious factor about the big data, velocity is very interesting factor. Can anybody give me any use case before I speak anything about the? Yeah, Yuruj, please go ahead.
Fact, we were speaking about the telecom example. So
Mm-hmm.
one of the softwares which is really existing in the telecom industry is like it's called as dynamic decisioning system or dynamic analytics system.
Mm-hmm.
So it I mean it's not really based out of Hadoop,
Yes.
but what I really wonder is like I mean what kind of information, like what is the volume on which we have to decide that we have to adapt Hadoop technology. So
Okay.
mostly most of the telecom providers really, if you see, I mean they have not yet adapted Hadoop just because it may not be required for them. The volume is not so huge. Whatever we have been calling about the customer complaints and all, it's just few hundred GB of data or a few 500 GB of data or so, which is pretty small amount of data. So what exactly is there any data limit which says that, okay, after this, usage of this technology might be very helpful?
Okay. Okay. So firstly, I would like to clear that Uruj, it's not like that. Telecom industry has not started using big data technologies. I have implemented Hadoop in TTSL, that is Tata Teleservices. I have implemented Hadoop in Reliance, two places, two telecom operator I myself have implemented. One of my friend is working on with Airtel 4G. So they have already accepted big data. They have already adopted big data. Very first thing, because it's not like any thing like that you have a certain volume of data then only go for this, or telecoms are not getting the good volume, huge volume of data. The currently the highest volume of data that is getting generated is from the telecom only. So since I'm talking with one of my telecom operator, so they are saying they are launching their new services, and the volume that they are getting generated is like anything. So their estimation for generating of the volume is per hour 100 TB of data from different sources, different things out there. Let me take the example of Reliance is launching a 4G. I'm sure you are aware of that. So the estimated volume that they are going to get via this 4G will be 100 TB a day. In initial first year of launch, it will be 100 TB a day. After that, it will increase exponentially with the number of customers. Now, what are the sources, or what even before that, what is the volume after which the user should go, after which the company should go, after which the client should go for big data solution? So it depends. It's not only about the volume, it's also about the processing capabilities people are using for the, say, if they are getting a day, say 1 TB of data, they are also using big data. People, you are, say, I'll give you the example of 100 GB data, just a 100 GB data a day, they are using also big data. So it's overall the problems that they are facing due to volume and due to the processing complexities, they are started using the big data. Say for example, you want to keep your last 2 years data in your repository, but it can't handle that volume of data. It can handle just last 6 months data. That is again the example of TTSL. When I visited guys TTSL, I told them, guys, I'll give you an infinitely scalable warehousing, because Hadoop is scalable to infinite. It's almost infinite the volume that they are getting generated currently. So apart from that, the third thing is telecoms are not generating volumes. Telecoms are generating volumes like anything. Like their each and every network element is logging their details, logging whatever about their n number of parameters. Like say for example the tower, the AAA, the other NCS elements, they each and every one of them are currently logging their a number of certain parameters about whatever they are delivering. I'm not sure how many of companies are currently analyzing, but companies like Airtel, companies like Reliance has already built the infrastructure. Currently in the big data, they are having their own data center. By the way, the number of servers in the cluster is very high, and even on this, the configuration of the servers is also quite good. The users data, say for example CDRs, they are expecting their CDRs per day will be billions of the records, which can't be processed with the RDBMS, which is far beyond the capacity of a single system. So guys, where you should implement the big data, wherever you are facing the issues. What issues it will be coming in next few slides only. There is a specific slide that okay, there are some issues with the conventional technologies. So if you are facing similar issues, you should go for this big data. You should go for big data solutions. Rich, fine.
Yep, yep. Also, like it would be good if you can discuss about where what issues and probably how to
Yeah,
solve
yeah,
them
yes,
and
yes, yes, sure. That are coming in next few slides only.
okay.
So yeah, I was asking if anybody, one of you can give me an example of velocity. No one?
Hello. Yes. Yashwant here. I would have to give an example.
Mm-hmm.
Hello.
Yeah, go ahead.
Actually, we have social networking sites and all that, at which we have more than millions of users connected at a time. This is, I mean, but still, the the big data, the data generated from this social networking site is able to handle. There must be any kind of such a algorithm big data must have, so that such a huge amount of data they are going to handle. Hello.
Yes, yes, Yashwant, but this is the example of volume. I was
No, no.
asking for the
What I meant to saying is
volume,
that
velocity.
parallel processing, parallel processing, there are millions of people connected to
Yeah, yeah, yeah.
connected to
I got it. I got it. So that's why there are those millions of people are generating huge volume of data, right?
at a time.
At
Yes,
a
at
time,
a time.
exactly. Okay, okay,
Yes, that is what I want to say.
okay. Another answer I got: predictive analysis on retail websites. Okay. But both of these answers are again pointing towards volume. Let me take the example of velocity. So guys, velocity means how fast the data is getting generated and how fast the data is getting processed. Say for example, I'm generating the data. Say I'm having, let's take the example of a credit card company, say Citibank. Citibank is having its own credit card. Okay, Citibank has given to it is having millions of the customers, and I think I'm getting some disturbance. Venkat, if you can mute yourself. Okay, thank you. So Citibank is having millions of the customers. Parallelly, millions of the customers are doing credit card transaction. How much time, by the way, guys, you take to do a transaction by the credit card? You when you purchase or when you pay bill or anything? How much time it takes for authentication when you go for a final checkout? After which you give the details and you press enter. You and give the card number and you press enter. How much time it takes? Oh no, Shiva, it doesn't take 3 minutes. It takes few seconds. Few seconds. 10-20 seconds. Guys, in those 10-20 seconds, I need to get the data collected at my system, and I need to find out, okay, what are the potential frauds which transactions are fraudulent? No issue, Shiva. Guys, imagine I'm getting currently parallelly streams of data. It's like a data flood is coming to my way, and out of which I need to find out, okay, say Makal Shiva is doing transaction from a new location. I need to firstly find out, okay, this is Makal Shiva and he usually do the transactions from Bangalore, from this particular laptop. Today his location has been changed to say Delhi. This is quite a big question mark. Okay, stop this transaction, send one-time password or take some other action. Uruj usually do not do the transaction for say any of ecom. Today he's doing this and it's quite a big amount. Again a doubtful case. Yashwant has connected to his VPN to his client. So his location has been changed to say US. And if he's doing the transaction, again a case of this. So guys, there are multiple and number of cases for the same, that your transaction can be considered as a fraudulent. Now again there are some degree, okay, 0 to 10. If it is 10, it will be blocked like anything. You'll get even call also, like it is you are connected to your VPN of your client and your location will be, let's say, US or other thing. But if it's not that much severe, they will send you a one-time password. But what thing I want to explain you here, guys, I'm getting TBs of data parallelly to my warehousing, and I need to process that and I need to find out, okay, is this a fraudulent or not? That's the real-time analysis. Let me take one simple example. As soon as you add any item in your cart, say for example while purchasing a mobile phone, as soon as you added mobile phone in your cart, if ecom can give you an offer that if you purchase this headphone with the mobile phone, if you purchase this cover, if you purchase this scratch guard, I'm giving you 20% discount. That's the real time. Hope you understood the real time. Guys, this is quite an important thing. What is the velocity? All of you, if you can ping me a smiley. One, two, three. That's good. That's good. Analyze customers searching buying pattern and show the advertisement of attractive offer in real time. While he's searching any product, while he's buying any product, I'm analyzing his pattern and showing him the advertisement. Take Google's example about processing of the data. So how many of you are blogging currently? Any of you? Okay, Riyaz and Shiva. Good. Yashwant also. So how long you're blogging means who are doing blogging from 2004, 5, 6? No one? 5, 7 years old? Okay. Let me take my example. When I was doing blogging in 2006, 7. At the time when I post my blog, it was taking 15 to 20 days to come in the search result. 15 to 20 days, guys, to come in the search result. By today, as soon as I post my blog and it comes into the search result, Google is scrolling the complete web like that much fast speed. Just imagine. That's the velocity. That's the true example of velocity. In Google, if we search about traveling, say shopping any electronic, apparel, shoes, watch, etc., or we are searching for the job at anything, the relevant advertisement it is providing us in real time while browsing any other website. Whenever we see Google ad, it is showing us the relevant advertisement. Advertisement for me is different if I'm searching for a mobile phone. Advertisement for Uruj is different if he's searching for a laptop. Advertisement for Venkat is different if he's searching for a job. It's highly content driven now. Variety. So guys, as discussed earlier, data today comes in all type of format, from traditional databases to hierarchical data stores that is created by end users and OLAP systems. 2. Text documents, email, meter collected data, video, audio, stock ticker data, and financial transaction, etc. If I say varieties of data in three formats, that is structured, semi-structured, and unstructured. If it is structured, I am having a very good solution, that is RDBMS. I can put my data inside that. But if it is unstructured, how I can put the data? Where I can put my data? Any one of you can suggest any of the solution for storing unstructured data or semi-structured data in the raw format? Where I can store this? Correct. Only example, file system. Put it in the file system and process it with your custom framework. But there was no standard tools. How many of you know understand the hierarchical data? By the way, this is also one of the form of data that is getting generated that comes as more towards unstructured side. No, Venkat, hierarchical doesn't mean Excel. It's something like this. I'm having multiple hierarchies. Like, say for example, I'm having is storing my information. Say for example, user info. Here I'm storing, suppose, his name. Here I'm storing his, say, address. So here his, so suppose inside address I'm putting his state. Inside state I'll put his, say, city, and so on. So that is an example of an hierarchical data. The data that is again and again multiple hierarchies are there. By the way, any one of you know which database provides native capability to store the hierarchical data? Venkat is saying Sbase. ESS base. Is it, Venkat? I doubt if it is having the hierarchical storage. Native capability I'm talking about. Shiva is saying MySQL. No, Shiva, MySQL doesn't provide. MySQL is just a flat format of rows and columns. One of the example for the same is MongoDB. MongoDB stores the data natively in the hierarchical form. Natively in the hierarchical form, guys. I can get all such information in few milliseconds by running the query. By the way, MongoDB is an NoSQL database. It's not a SQL database. It's a NoSQL. What is a NoSQL database? Any one of you would like to speak anything? Uruj, Shiva? Simply English statements. No. I'm not talking about the data. I'm talking about the NoSQL database. No one?
So it's like not only SQL supported databases, right? Like data is not really to be a schema based. Data can be, we don't have any fixed format, any schema. Like how we have in SQL databases, we need a fixed schema to access the database. So that kind of really things will not be there for NoSQL database. So the data can be stored in a variety of formats, like how MongoDB stores the data in JSON formats. There are graph databases, so each one may not need to be a fixed schema driven, and moreover, these databases, not only the SQL, you can access it through a variety of other ways, and also that these are all mostly distributed databases where
Correct.
they support one of the two of the three combinations, like going to the CAP theorem back, so it supports some combination of consistency, availability, partition tolerance. So it supports some of them. So that combination comes into NoSQL databases mostly.
Perfect answer. Perfect, Reyes. So guys, NoSQL database come into the picture where SQL database stop answering your request. SQL database stop fulfilling your requirements. Up to millions of records, your SQL database are best, or I should say up to lakhs of records, up to thousands of records, they are best. Up to million it can work, but going forward for the billion of records or for the trillion, your SQL databases are not the solutions for even normal data also, normal structured data also. Even I'm not talking about the hierarchical or graph data or the images or other unstructured data. Surely those type of data are not stored in the structure in the SQL databases. So for all such cases, NoSQL database like MongoDB, please note down the name MongoDB, Neo4j, HBase, Cassandra, these NoSQL database come into the picture. Why it is called NoSQL? Because they doesn't understand SQL queries. You need to either write your own code, you need to run the commands to access the data, to process the data, and so on. This is one of the example of this NoSQL database, MongoDB. So if you ask me for more example of the data, different type of data, different variety of data, I would say guys, A is connected to B and B is connected to C. So this is what is the degree of relationship between A and C. Almost all of your social network sites are using this to find out your friends of friends, to find out your first degree and second degree connections. So this is the direct connection. This is the first degree connection. This is the second degree connection. And this is third degree connection. If I want to store same thing in say normal RDMS for this particular commutative relationships, it's very costly. It's costly like anything. It will take days to process the data, days, not hours, not minutes. But if I go for the NoSQL, if I go for the graph databases, it will give you the results in milliseconds because it is natively stored in that manner only. Can you name a few NoSQL this graph database? Any one of you? One example of the same is Neo4j. Please note down the name. Do a little bit googling about this as these are not the part of our syllabus. Neo4j. Yes, Shirish, correct. Let me type for you. Let's go ahead. So guys, for storage of structured data, you have got RDBMS, but for the storage of semi-structured and structured hierarchical graph database, you don't have any solution. That needs a cost-effective and quite an innovative solution. That's why big data technologies came into the picture. Graph. Okay, let me type. Graph database. Tree. Okay, Aruch? Fine. The fourth dimension is veracity. So a data warehousing professional can understand the veracity thing who has deal with the raw data. Big data veracity refers to the bias, noise, and abnormality in data. Is the data that is being stored and mined meaningful to the is it meaningful to the problem being analyzed? Veracity in data analysis is the biggest challenge when compared with the volume and velocity. Keep your data clean and process to keep dirty data from accumulating in your system. Guys, today data that is we are generating the data. There are lots of noise, there are lots of abnormality, there are lots of ambiguity, there are lots of repetitions, and number of things and number of issues are coming with the data. When I'm collecting the data from social media, is it just a unique records? Is it the complete record? Is information complete? No. Are they unique? Is there no repetition? No, there are repetitions. There are lots of dirtiness in the data. I'm collecting the data for sentiment analysis. People are doing lots of spelling mistakes. I can't do anything in that, right? So this is again one of the very big challenge, one of the very big factor in the big data. Whenever a natural language processing things come, whenever people are interacting with, they are typing by themselves, there are lots of abnormalities in data. Even while we are collecting the data, while the data is traveling, some data getting lost in the network. What about that? All such things come under the veracity. That is data in doubt. How I can remove, how I can move that doubt. So again, different type of strategies needs to be developed for different type of problems. So guys, we have talked about big data. What is big data? Why big data? What are the places where you can use the big data? What are the different essence of big data, different dimensions of the big data? But let's talk about little historical things. These are currently, I should say historical thing only. These are the conventional approaches which were in place for the storage. As almost all of you have seen, for the storage, people are using Oracle, DB2, MySQL, PostgreSQL, etc. For the storage of structured data. What about unstructured data? OS file system. And for the processing of the same, people are using SQL queries for the RDBMS, and for OS file system, mostly I see with my client Perl plus CC++ framework. This is the combination that I have seen mostly in my clients. What are the problems? So before that, why big data technologies? Conventional approaches or technologies are not able to solve current problems. They are good for certain use cases, but they cannot handle the data in the range of petabytes. What are the problems with the conventional approaches? So guys, where you should implement the big data, where you should start thinking, okay, I should recommend my client, I should recommend my team, let's deep dive into big data, let's start big data solution, let's start using big data technologies. These are the pain point. These are the areas that we are supposed to do. I've got one thing, let me read. Oruj, sorry, slip that what I wanted to ask regarding the issue before. So typing down what issues and what it costs installation and maintenance when compared to the traditional technologies. Yeah, Oruj, surely I'll answer this. So Oruj is asking, so what type of problems and what so we should use, and what are the costs and what are the issues and also, yeah, with this slide your doubt will surely be clear. So guys, when we are using these conventional technologies early 2000s till mid 2000s, that is 2005 2006, it was quite good, one of the best solutions. There was not that much huge competition in the market. People were not analyzing all such things of, say, web related things, say customer related things and all such things. But since the usage of internet is increasing, since the usage of social media is increasing, since the competition in the market is like anything today, since e-commerce is increasing, coming into the market like anything, your telecom, your this smartphones are coming, new apps are coming, so data explosion is coming in the market. There is a data explosion in the market. There is a data explosion. Data flood is coming to your data center. Since the volume of data is increasing, even can take your example earlier when you were clicking the picture. I have clicked a picture of 1 KB also. Today I'm clicking a picture of 7 to 10 MB. Per click is 7 to 10 MB or even more than that. So guys, you can imagine 1 KB to 10 MB. How much is that? 10,000 times. Guys, 10,000 times is quite a big. I can recall my desktop at my home. It is, I think, 20 GB. I haven't, it's still there. 64 MB RAM, 20 GB hard disk, 20 or 8 GB hard disk. I can recall exactly. Currently, I am having my storage 10 TB storage. I am having at my home. Apart from that, I am using Google Drive. I am using Dropbox. I am using this, that, and all such things. This is the requirement because your requirement has been increased. That's why this hard disk and all such things are there. The very first pain point that I've seen industries are facing limited storage capacity. If your data warehouse, if your warehouse is on a single system, you are going to face a limited storage capacity issue. Let me take the example of TTSL. They can store, I'm talking about their IVR and call center data. They are able to store just last 6 months data on their current production system. Just last 6 months of data. Why so? Because the data that is older than 6 months, because the volume of data is high, the data that is older than 6 months, they need to archive it to tapes. Now you'll say, okay, no issues, I'll archive, but there is a twist in the story, because they're frequently getting the requirement from the client that they want reports that is data older than 6 months, that are like last 1 year data, last 2 years data, and so on like that. Now what they need to do, they have again purchased one more monster system, that is again 500 gig RAM, 128 core processor and all. They are loading the data back from tape to analytics system, that is second system. Now the loading of the data from tape back to analytics system, it usually takes, depends on the volume, usually takes 36 to 40 hours. Business needs to wait for that much amount of time. 36 to 40 hours in today's time, guys, what are you doing? And for some of the report, they daily need to get the data from archive location. Again, after keeping it for some time, they need to again delete from that data that they have already backed up in the tape. So guys, when I visited TTSL, I told them, boss, this is a very big pain point. Who will wait in today's era for 36 hours for a report, even just for the loading of the data? They are creating different sort of policies, different sort of procedures. People are staying in the database, in the data center 24/7, who are continuously archiving the data that is older. You are continuously maintaining the data. I told them, boss, if I give you a platform which is infinitely scalable, so they told it's impossible. I told, boss, that is scalable. Today, if your requirement is say 10 node cluster, 10 machines in the cluster, I'll explain you what is node, what is cluster, what is all such things in tomorrow's session. If your requirement is a 10 node cluster, just deploy a 10 node. Tomorrow, if your requirement is increasing, because nobody can predict about your if your business is super duper hit, you're expecting say 1 million customer, you have got 100 million customer, you're surely not saying them to buy, don't come. I'm expecting only 1 million customer. So the volume of the data will be again very huge, and with the business increasing, again the type of the data, sources of the data is also increasing. So if I can provide you a scalable system which can be on demand, I can increase accordingly whenever requirements are increasing. It's very, very big pain point. Same pain point I have seen in the telecom industry, same pain point I have seen in retail industry, and with many of my clients. Now, second issue, limited processing capacity. Guys, your SQL query is working on a single machine. There is lots of parallel queries are going, parallel data is getting loaded, parallel data is getting archived. So this query, that is the report that is getting generated. To some of the reports for TTSL, it was taking more than 4 hours. Not 10 hours, sorry, more than 4 hours. Yes, 4 hours is again a very big time. Those reports, I accept that it's complex. But if somebody is loading the data, somebody is archiving the data, a number of users are hitting databases, so surely this will be the very, very big performance bottleneck. Second issue, limited processing capacity, is the same issue I have shared with that XML data processing, that invoices for that retailer, 100 GB. Their processing capacity is limited because of single machine is processing the data. No scalability. Can you scale your RDBMS system, that is a single node cluster, single node system where you have deployed Oracle? No, you can't scale that on the fly in the real time. You can't scale that. There is no methods available for this. So if my requirement is increasing, still I can't do anything. I can't scale my system. Single point of failure. If your system goes down, guys, what will you do? You need to wait until your system will come up. Sequential processing on a system that is on a single machine, that is running on a single machine. You can't get a true parallel processing there. RDBMS can handle only structured data, and we have seen 80% of the data is unstructured. What about the 80% of the data? You can't store the raw data as it is. You need to pre-process the data, but the information is collected according to current business needs. What do I mean by that? So guys, when I was working with this retailer, they are getting 167 parameter from last 2005. From 2005 to till date, they are collecting to 167 parameter, but that is in the form of XML. They are pre-processing that data and converting it into a structured format. Out of 167 parameters, they are just taking 47 parameters. Out of 167 parameter, that is just getting 47 parameter. Rest parameter they were dumping off. Why? Because when they designed the application at that time, those were having just the blanks. But with time data was coming and they didn't even started loading the same data. This is a very big issue, because guys, in the data warehousing industry, wherever you are dealing with the data, big data, any of them, you're supposed not to lose a single byte of data. Single byte of data is a big money. Even a single byte of data also. Data is a money. So guys, what I mean to say here, please try to understand this point clearly. You might face similar issues. Today when you pre-process the data, you pre-process the data according to today's requirement. That's why currently in the industry, the terminology of ETL has been changed. Currently, the data scientists, data practitioners are asking to store the raw data as it is. By the way, guys, what is ETL?
Extraction, transformation, and load.
Yes, extract, transform, and load. So we need to extract the data from the source, transform it according to our requirement, and load it into warehouse. But it has been changed, ELTL. That is, extract data and load it into raw format as it is. Then format, transform it, and then load into warehouse. This is the recent advancement in the industry. This is even, you can't find much thing on the Google itself. So guys, these are the problems with the conventional approaches. These were the problems with the conventional approaches. These are the pain points, major pain points that people are seeing today. Some of them are not capable of storing, some of them are not capable of processing, some of them are not capable of scaling or sequentially processing or parallel processing and all. So let's talk about a little bit more about the limited storage capacity. Since your system is installed on a single machine, it is having the specific storage limits required to archive the data again and again. So problem of reloading data back to the repository according to the current business need. That is again very big pain point. Only process the data that can be stored on a single machine. You can't process the data that is beyond a single machine's storage limitation. storage capacity. That's limited storage capacity. Regarding limited processing capacity, because since again it is installed on a single machine, it is having specified processing limits, have certain number of CPUs, not able to process the large amount of data efficiently. Because say if you are having 64 core processor, hundreds of the users are hitting, CPUs are divided between all hundreds of the users, it can't process the data efficiently, large volume of data it can't process. No scalability. One of the biggest limitation in the conventional RDMS is the no scalability. We can't add more resource on the fly. Guys, by the way, what's the meaning of on the fly? In real time, without any downtime. That's all about big data introduction. So Uruj's question, I think I have cleared about in which sources, in which condition, what are the issues, what are the problem, where we need to think about, okay, where we should go for the big data solutions. But what is the cost? I'll come to this tomorrow, because big data solutions are pretty cheap. They are pretty economic as compared to RDBMS, as compared to the conventional technologies. Guys, any questions? So today what I tried to give you an overview, overall picture of the big data, why everybody is talking about the big data, what were the problems people were facing, so that they have started migrating to big data. Nobody will move from their usual practices to a new practice until there is a requirement, until there is a big requirement, because always we have the intention of stay away from the change. This is normal human tendency, but there is surely lots of big pain points, lot of big problems due to which people are migrating from conventional technologies to big data technologies. So what I tried to present an overview and complete picture about the big data. What are the typical use cases? What are the typical industries they are started developing, they are started deploying the big data things? What are the problems that you can solve with the big data? And so these use cases and the problems will continue till the end of the sessions, that these are the problems you can solve, these are the use cases that you should go ahead with this. Yes guys, any questions?
Not a question, but one of the one things.
Mm-hmm.
Are you going to also, like, I mean, what are the associated or related technologies? Like, assume, like, if I want to, based upon the data, if I want to do some kind of chart, draw some kind of charts or graphs or so.
Mm-hmm.
So there are a lot of products available.
Yes.
So while going through the examples, like, if possible, can you mention the associated or related technologies, like which we can use along with the big data?
Yeah, sure, Uruj, I'll incorporate all such things also during our sessions. I'll mention all the related technologies. So usually typical analytics procedure is getting completed from starting of the ETL, that is collection of the data, pre-processing of the data, loading of the data, then data marting, then after that visualization. So we are going to see end-to-end things, don't worry.
Okay, visualization also we have. That's
No, actually visualization is not the part of our session. ETL is not the part of our session. But what are the tools available for the same? We are going to see. We are going to talk about that also.
okay, sure.